Okay, so it is the 27th, 9, 27, 18. So the book wants to call this, Josiah, let me teach, okay? Hold on. The book wants me to call this special factoring, but it's not special at all. I mean, we're still going to do the same thing, parentheses, 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 right? The only way we can make an s squared is with an s and an s, right? Yes. And if we want to make a negative 49, it's a positive 7 and negative 7. It's that easy. Now they want to call that difference of squares. So the title would be difference of squares. Because it is a perfect square minus a perfect square. You need plus or minus make a negative 49, right? Oh. But it's super easy. Now if you did your double smiley, you'd get a negative 7s and a positive 7f, which makes no s's, which that's true. There's no middle term, right? So it's nothing special about it. Ellie, real quick, yes. Absolutely, yeah, absolutely. So if we take a look, for instance, at number 2, you know it's got to be t and t, right? And again, Ellie, what's the square root of 81?
9.
9, right? So it's plus 9, but it's got to be a plus 9 and a minus 9. Isn't that easy? And then on number 3, it's just written backwards, but it's still the same thing. We're still going to go 4 plus x, 4 minus x. That's it. Isn't this easy?
Not write it the other way, is it wrong?
It would be wrong if you wrote it the other way, yes. And I'll tell you why it would be wrong. If you wrote it the other way, Zoe, you'd wind up with a negative 16 and a positive x squared, and it's not. You need a positive 16 and negative x squared. Does that make sense if you wrote it the other way? Okay, now, they can get a little bit complicated, but not too bad. If we look at 5, 5 is really not that hard at all. It's just more square roots of just more things, so it'd be a 6h plus 11 and a 6h minus 11. Right? Isn't this easy? Yeah. Super easy. And you could check the double smiley. The middle term is 0, right? Now, if we shift over to page 67, they're going to call these as special factoring also, but it's still the same thing we've been doing. And you'll see why this is unique, but it's really pretty easy. I don't even like to call it a special factor. It's just factoring. Josiah, yes, great. Yes, you may use bathroom. Yes. So, if I factor 13, we're going to do the same thing. The only way I can find an x squared is with an x and an x. What are the multiples of 64 that add up to 16? 8 and 8. 8 and 8. So plus 8, plus 8. Okay, so plus 8, plus 8. They like to call this a unique kind because it's plus 8 twice, right? Or you could write this one as an x plus 8 quantity squared. Both of these are correct. I wrote it as x plus 8 quantity squared because it's the same thing twice. It's multiplied to itself. Does that make sense why I can write it like that? Okay, how about number 14? How about 14? You know for sure we're going to go P and P, right? And then 196 is probably a perfect square, probably. But if you're not sure, then let's just figure it out on a calculator. What is 196? If I try this,
14.
Yep, square root of 196 is 14. So probably 14 and 14, and we know 14 plus 14 makes a 28, right? Plus 14 plus 14. We know if we did our double smiley, we get a 14p and another 14p, but we could rewrite as p plus 14 quantity squared. Okay. Now, they're not that difficult. So if I took a look at 16, same kind of thing on 16, factor, right? I'm going to have an a and an a because of a squared. And then, of course, what times what makes 81? 9. And 9 and 9 makes an 18 if we put them together. We need a negative 9 and a negative. Has to be negative, negative. Totally correct. Negative, negatives, right, Zoe? Because that would make the positive 81, and when I add them together, the negative 18. Or a minus 9 squared, right? Now, 17 is a little bit more complicated, but it's still going to be the same stuff. But we're going to check it to make sure, but I'm going to go parentheses, parentheses. I'm going to go 6c, 6c, because that'll make my 36c squared, right? And I'm going to go probably 7 and 7. I'm going to go probably 7 and 7, probably plus 7, plus 7. But I'm going to check, because if I'm wrong, and how do I check? I check with the double smiley, because I don't need to check 6c times 6c. I don't need to check that. That is definitely 36c. I don't need to check 7 to 7. What I need to check is the middle term, right? So if I do my double smiley, let's see what I get. I get a 42c, and I get another 42c, which sure enough makes the 84, so I got it right. And if I want to, I can rewrite as a 6c plus 7 quantity squared.
We learned this last year.
Yes, we did learn it last year. Some kids didn't have me last year, so you know this new book that you may or may not like. One of the things I like about it is that you'll see this spiral from course to course to course. So by the time you see Mr. Massey in pre-calc, you're going to know how to factor, right? Yeah. In fact, I was just talking to Molly. Molly's in pre-calc, and Molly's in calculus, and she goes, "Oh man, I'm so glad I know how to factor because there's a lot of factoring in calculus." So if you're going to head that route, let's make sure we know how to factor, right? And you guys are. So moving on. So at 19, let's solve. So these are actually pretty easy to solve. Has to be two answers, right? Has to be two answers because of the x squared. Two answers, two zeros, let's call them zeros, two zeros because of the x squared. So if we factor, I'm going to go x plus 12 and x minus 12 equals 0, right? And then I'm going to just solve, and I'll get x equals a negative 12 and x equals a positive 12. Now I skipped a step, but you're okay with that, I'm sure, right? I mean, you're okay with me skip the step from here to here, right? If I just solved, I just minus 12, right? Just add 12, okay? Let's look at 20. Now, the thing we have to do on 20 is it's called finding zeros. Say it again, listen, listen, listen. It's called finding zeros. So we have to set it equal to 0. It's called finding zeros. So we have to set it equal to 0. So I bring over the 49. And I'll make it a 9y squared minus 49 equals 0. So we're finding zeros. So let's set it equal to 0, okay? If we're going to factor, that's easy. We're going to go a 3y plus 7 and a 3y minus 7 equals 0, okay? Two equations. Two answers. One answer comes from 3y plus 7 equals 0, and the other comes from 3y minus 7 equals 0, right?
Sure.
Minus 7 minus 7, 3y equals negative 7, divide by 3, and I get negative 7/3. Did I go too fast on that?
Yeah.
Okay. So I went minus 7, then I divided by 3. And that's like, what, negative 2.3333333, or I like negative 7/3. It looks easier, doesn't it? And on this one, same way. We're going to go plus 7 plus 7, 3y equals 7, right? Plus 7 plus 7. Divide by 3, you're right. Josiah, divide by 3, and it's going to be 7/3, okay? How's that? Pretty easy? That's all I have. So what I'd like to do is practice on a little Kahoot I found.